So normally I try to have my video up as far as my webcam as well, but unfortunately I have to try something new. So let's see if we can do this here. Alright, so our instructions are to simplify this particular problem. And as you can see, we have different denominators, so how unfortunate for us. We're going to have to kind of factor this out because that's the way we started. So the first thing I'm going to do, and I gave myself a little bit of room. If you've seen my videos before, that I usually put it in the center. I'm going to need some scratch paper, so we're going to do this over here. But I'm going to start, maybe, by factoring. And because, wow, it's been a long time since I've made a video because my handwriting is terrible. But we're going to start by factoring all of the denominators. Now we may have to do some additional factoring later, depending on what's going to come out of this. But because it's addition and subtraction, and we're going to have to combine the numerators at some point, we're not going to factor the numerators, even if they are factorable. Alright, so let's take this. Let's start with x squared minus 9. This is a difference of squares, so when it factors into the sum and difference of roots. And then we can rewrite this piece here. Come on. What in the world? Oh, no, that should still work. Oh, I know why. I know why. Let me see if I can fix this here. There we go. Okay, got it now. I had my layering screwed up. Alright, so now we can rewrite that there as x plus 3, x minus 3. Take a look at this 3 minus x. It looks extremely close to the x minus 3. And in fact, we can make it look so by factoring out a negative 1. So 3 minus x, we can make that look like negative 1 times x minus 3. This is actually a formulation of a trick most people use when they're subtracting off, say, two numbers where the second number is larger. So if you have something like 5 minus 8. Even though it's supposed to be 5 minus 8, most people will actually determine it as, okay, what's the difference between 5 and 8? It's 3. But because I'm trying to subtract off more than I have, it has to be negative. That's the exact same thing. This is just a mathematical formulation of the normal thought that people have. So we can rewrite this as negative 1 x minus 3. Alright, that being said, let's rewrite this whole mess because we're going to have to do the thing now. So my step 2 is do the thing. I keep this vague on purpose. The thing is whatever the operation is and whatever the structure it happens to be. In this case, it's fractions, so we have to have common denominators when we're adding. And if it was multiplying, I'd still leave it as do the thing, but we could use a different rule for multiplying. So we're going to have to do the thing. If I take this here, this is going to be x over x plus 3 plus. And now, it depends on where you want to stick this. I'm just going to stick it in the bottom for right now. I may decide to do that or change that later. But I'm just going to kind of keep everything where it is for the time being. X squared plus 4 over, and we have x plus 3, x minus 3. So what we're going to want to do is, because we need a common denominator, we're looking for denominators that don't exist in the other ones. Here is where I'm going to do myself a favor, and I'm going to take this negative 1 and I'm going to move it to the top. You're like, whoa, 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 you can't do that. But see how we're multiplying and dividing? It's just changing the sign. The sign can change on top as well. The effect of it is something like this. Negative 3 over 4 is the same as, or is equivalent to, negative 3/4, which is also equivalent to 3 over negative 4. You can put the minus sign wherever you want. It doesn't really change anything. You might have instructors out there going like, oh, but you can't. Okay, technically you can, however, there are some advantages to putting it in certain locations. So I don't know as if I'd jump on them right away, but I would certainly ask them, well, why can't you write that? And they might, as soon as the word style comes up, stop. Because if you've heard my rants about English before, that's always my biggest. Well, that's not the style. Style is for me. It's only for me. So, yeah. I'm sure I'm going to get some hate messages on that one. But it'll be alright. Okay. So we still have to do the thing. We really haven't done anything yet. What we need to do is find out what's missing. Well, the -1 is no longer there. So let's go ahead and get rid of that. I moved it to the top. So we don't need that anymore. That being said, we still need an x plus 3 here in order to match this third denominator. Well, we can't just throw it in there. We have to also throw it in there on top. So we're going to have to do some dirty 4-letter F wording. And again, if you haven't watched any of my videos, I do not use the dirty 4-letter F word. It is an awful word and should be stricken from the English language. Let's see. Okay, so the first one here has an x plus 3, but it's missing this x minus 3. So we're just going to put an x minus 3 on the bottom and x minus 3 on top so that we don't change the value. Alright, so now looking at our denominators, I have an x plus 3 and x minus 3. I have an x plus 3 and an x minus 3. And I have an x plus 3 and an x minus 3. Life is good. Alright, so let's go ahead and let's send this over. And let's go ahead and what we're going to do is going to distribute all this out. So after distribution, we're going to have x squared minus 3x, keeping in mind that this is all over the common denominator of x plus 3, x minus 3. These two factors can go in either order. Do not recombine them, please. It's going to be in your best interest to not recombine them. Please, please. Moving on to the next thing, and I'm going to change colors here just to kind of show you the difference between them. I'm just going to pick a good color to do it. What I need to do is I need to dirty 4-letter F word these out, and you might recognize what I'm doing here. I shan't say the word because it's evil. But then I'm going to multiply each of my pieces by -1, and I'm going to add that in. When I do that, effectively, what becomes the operation is the sign of the term. So, to give you an example, I have x times x for x squared times -1 is going to give us negative x squared. If this was a minus sign here, I would have actually multiplied or distributed this negative to the front, changing it to a plus. Would have made our lives easier, but of course we can't have that. So the next piece, I have x times 3 is going to be 3x. But then I have a 1 times x for a 1x, so that's going to be 4x's all together, and it's going to be negative, so negative 4x. I did the O and the I of the dirty 4-letter F word, by the way, together. So I just kind of did that in my head. And then 1 times 3 is nothing but 3 in the positive. However, this -1 changes it to -3. And then finally, we don't have any changes to go on the back end, but we just throw in this plus. This plus carries on through. And so it's going to be plus x squared plus 4. Now, I'm still doing the thing, so we got to be cautious. And I'm going to clean that up. So I still have this x plus 3, x minus 3. And then up here, I take my x squared and my negative x squared are going to cancel, leaving me with just an x squared. So I'll change that to, let's change it to orange. Then I'm going to have my -3x, my -4x, and I don't have any x's over here, so this is going to give me a -7x. And then I have this -3 and a +4, and that's going to give me +1. So, as we're moving through here now, we have to decide, is this thing factorable? And the answer is no, it's not factorable, because I would need two numbers that multiply to 1 that add to 7. And if you can find me two numbers that multiply to 1 to add to 7, go right ahead. But without some fancy schmancy other math that we might need, we really can't factor that out. So this is it. That's the answer. That's all that's all it is. It's unfortunately all she wrote. There's nothing more to do. So, if there was something else to do, my third step would have been to factor. So I would have continued factoring if I could, and because the factors would have given me multiplication throughout the entire problem at that point, I would have canceled where I could. And that would have been my reduction. Wow. Whew. I need to go back to school on how to write. But that's it. That's adding and well, in a sense, adding and subtracting rational expressions. I hope this helped.